So yeah, as we all studied in last class, like free body diagrams and introduction to laws of motion, and as well as Newton's first law. So let us once again go through the Newton's first law, and we'll continue the numericals in our today's class. So as we all knows that Newton's first law, if you want to see that, if you go back to the class 9th, Newton's first law will says that what the Newton's first law according to the class 9th, everybody, all of you.
Law of inertia.
Yeah, law of inertia, we can say, of course. So, law of inertia means in the sense of the body which is in state of rest remains in state of rest. The body which is in uniform velocity in a straight line, uniform velocity in a straight line remains in continuous, like remains in motion until they must be experienced by a what? Unless they compelled by an compelled by an external force. So 9th class I have taught, that's why Prados is remember. So external force. So that is what Newton's first law we can say, or we can say law of inertia we can call it as. Now if you have noticed it, the same thing here also we are studying. Newton's first law means the body which is in state of rest remains in state of rest. The body which is in uniform motion in a straight line remains continuous its motion unless they experience it by a what? They compelled by an what force? External force. Now let us see Newton's first law. What Newton's first law we discuss everyone? Total net force is equals to, it must be equals to what? Everybody. Total net force is equals to 0. In the sense of, if I consider one body, it may experience it by many forces, like whatever multiple number of forces it may be experienced. So the sum of the total forces, F1 force, let me take F1, we all knows that F2, this is F3, let me take F4. So we all knows that force is a vector quantity or scalar quantity. Everybody? It is a vector quantity. So sum of the individual forces, if I do that, that is what equals to total force. So must be equals to how much, everyone? Must be equals to 0. That is only ways to called as Newton's first law. So means in the sense of the object which is in state of rest remains in state of what? The
Rest.
object is in state of rest, remains in state of rest. The object is in motion, that is what, with a constant velocity. Constant velocity. There is no change. There is no change in its velocity. Till where, what time? Unless they compelled by an external force. That is what Newton's first law. So Newton's first law also we can call it as law of inertia. So this F net, that is what net force exerting on a body must be equals to 0. So this is only ways to call equilibrium position. Okay. So the body is said to be in equilibrium if the net external force, the forces, the net forces which are acting on the body will become equals to how much, everybody? Sai Karthik, which is equals to 0. Clear? So if it is the same string, last class we studied that if the same string, the tension acting in the string is remains same or varies, everybody? Remains same. That is what? Sir, no. The string, unless the string will change, the tension will never change. That is what we studied. Am I right, everyone? Please respond. Yes, that's what. Now, let us solve some numericals in our today's class. We'll see that how to find the tension in the pulley questions and all. So question number 1. So you must need to find it. So let me take a rigid surface. Okay. Now, something, a body is attached to the string 1. So that is what, let me take it is a 2 kg. And another string is attached. That is what it is. Body is, let me take 5 kg. So now, first, tell me the tensions. Now, in which string having more tensions? Upper, first string or second string? Who is having more tension? All of you. First string or second string? Let it be. First, second string, always the force exert away from it. Let me take that is what T1. Then here also it is away from it. Because same string or different string or? Same string. So here also how much it will become? All of you. T1. Am I right? Next.
Yes.
The force exerted by this string is changing, so tension will change. Let me take that is T. Then here the string is attached to the rigid body. That is also it will exert the tension is what? All of you.
T.
Same string. Same string means same tension. Understanding? Different string means different tension. So same string, same tension. Now, what is your expectation? In which string the tension will be more? First string or second string? Anybody? Yes, please.
First.
First string. Why first string? Because first string is carrying the both the weights, but second string is carrying what weight? Second string is carrying what weight? Only 5 kg. Understanding? So that is what you should understand. So free body diagram. Let us draw for T1. So we all know free body diagram. Can you tell me how it is the free body diagram for T1? So first 5 kg. So this is the mass, 5 kg mass. So we all knows that something is acting downward direction. So who will act downward direction?
Weight.
Weight. So weight is equals to what?
mg.
So m is equals to 5. So how much it is? 5g. Clear? Then somebody is acting upward direction. Who is that? T1. Clear? All of you? So that's all. We'll understand that. From that both are equal. So T1 is equals to how much? All of you? 5g. So we all knows that g is equals to 10. Then the tension in the first string, second string, which is equals to how much? 5 into 10, which is equals to how much, Ra? All of you? 50 Newton. So tension in the first string is how much we got? All of you? We got it is a? Yes, please.
15.
Respond. 50 Newton. Understand? Please respond.
Yes, sir.
All of you, that is what. Next to T1, we have to find it. Then T1 means tell me. So T1 means something. You have to observe very carefully here. So again at this point, 2 kg. So 2 kg is the free body diagram. So if I draw 2 kg here, something is acting upward direction. So that is what we used to call as. What is that? All of you.
T.
T. And next, down is acting two things. One is weight, another one is tension T1. So one is T1. One is T1, another one is acting something. What is that? Weight of the body. So what is the weight of the body? All of you. 2g. Am I right or wrong? Yes.
Yes,
so
sir.
two forces are acting downward directions here. So T is equals to 2g plus T1. Then T is equals to 2 into g value 10 plus
10.
T1 value 50. So T value how much it will come? 20 plus
17.
50. So T is equals to 70. Do you all understand, everybody? That is what. So
Yes, sir.
why
Yes,
the
sir.
tension, why the tension in the first string is greater, all of you? Because it is carrying the both masses. That is the reason the tension will be higher. Ellame puriyuma? Understand?
Yes, sir.
So please solve it. So keep it in mind that how to find it tension. This is the way we should solve. So whenever we speak in physics, keep it in mind. So equilibrium position. If you all notice it, equilibrium position means in the sense of the force in x direction also zero, resultant force. The force in y direction also zero, and the force in z direction also how much? Resultant force, which is equals to 0. So that is what we used to say equilibrium position. Okay. So the resultant force, always the net force is equals to how much? Everybody? F net. F net is equals to, here you see that. F net is equals to how much? All of you?
0.
That is what you have to remember. Understand, Ishali, Monish, Mr. Rishi, Sai Karthik?
Yes, sir.
That is what you have to remember. Any doubt, anybody can ask. Clear, Mr. Udreswa?
Yes, sir.
Okay. Yeah. So first question. Any doubt, anyone can ask. Shall we start next question, everyone? All of you? Yes. If you are ready, then I'll give the question. So let's start. Question number 2. Okay. So let me see who will solve first. So question number 2, try, unless you think you people cannot. So let me take now one body who is having a 5 kg. How many kg? All of you? 5 kg. So which is attached to the another surface, another rigid surface, and this is the one surface. So now, and I'm giving only one clue. With this angle, it is making 37 degrees. How many degrees, everybody? Ellame. 37 degrees. So unless you use the properties of lines, you people cannot solve this equation. That is what lines, intersecting lines. So that is what it is. So now observe very carefully. I'll teach you. So 5 kg, something is acting downward direction. What else it is? Fastly.
Weight.
5k, weight. Weight is equal to what? Mass into
5.
acceleration due to gravity. So how much it will come answer? 5g. Right or wrong? All of you? Now tension exerted by this one. String changes. So tension will changes. Let me take T1. Of course, this is also exerted by the same tension, T1. Now here, tension changes. So the exerted by this one, how much it is? T1 or T2? All of you. It will become T2. So this is also T2. Any problem, Pradosh? Rudreswa? Clear? Please respond. Now,
Yes, sir.
all of you observe very carefully here. We all know, let me imagine this is like a two lines. So two lines, one is intersecting. Now, if I draw perpendicular line here, if here is the 37 degrees means, then here also how much angle? If I draw here perpendicular, here also how much here? Everybody, please respond. How much is the angle?
37.
37. Ellame puriyama, you understood? I want to know the response. Clear?
Yes, sir.
All of you. So with that only we can able to solve it.
Yes, sir.
So here also how much is the angle? Here also angle will become fastly 37.
37 degrees.
Okay. So let us make at that point. So let us imagine this is the point, and you tell me what is the forces are acting on this body. That's all is our question. If you make the free body diagram, mudinjicha. So free body diagram. This is what 5 kg. How much it is? 5 kg.
5 kg.
So 5 kg. So the force which is acting on plus x axis. What is that? Tension. Who is to consider as fast? T1. Am I right or wrong? And one weight. Weight is acting downward direction. How much it is? 5c. Am I right?
50.
But another tension which is acting with what is the actually resultant force. Have you all experienced it? It is not a x-axis or y-axis. That is T2. In what direction it is? Resultant force. Ellame puriyama. Please respond. So resultant force, it is making a theta angle. Then what will happen? X-axis and y-axis. So y-axis, what will happen? For example, this is the F. So here what will happen? F sin theta, and opposite what will come? All of
Cos
you.
theta.
F cos theta.
Cos theta.
That is what. Remember? Okay, brothers. Sai Karthik? Yes, that is. So it is making a theta angle. So this is the theta angle which is making. So that is what we are studying here, theta angle. So theta angle means then we all knows that. So here what will happen? T2 cos theta, and here what will happen? T2, everybody, T2 sin theta. So theta is equal to how much, everyone? We all knows that. Theta is equal to how many degrees? 37 degrees. So here what will happen, Rudraswa? T2 sin 37, and here what will happen? Fastly, T2 cos 37.
And
So we
cos
all know
theta.
that if
Cos
it is a 37,
37.
if it is a 37, by this time your mind should say something. Anybody can tell?
3, 4, 5.
Yes.
3, 4.
Popular triangle which in LMA everybody knows. That is what we all knows that. What is that? If angle is 37 degrees, only 53 and 37, then what will come here? Opposite side 3 and adjacent side 4, and
3.
hypotenuse is how much?
Hypotenuse.
That's all. Then we all knows that sin 37 value. Everybody, sin 37 value 3 by 5.
3 by
3 by
5.
Yeah, cos 37 value fastly 4 by 5.
4 by 5.
Naren, you
4
may
by
not
5.
understand, but you have to watch the videos, then you will understand easily. That is a very popular triangle in second chapter and third chapter. Okay. Yes, two triangles are there. So one is 53 degrees and another one is that. Many times, by this time we have solved minimum 100 times we have taken that values. That's all, guys. Then you tell me from this. So T1 is equals to what? T1 is equals to what? Opposite forces are equal. So T1 is equals to what? Fastly. T1 is equals to T2 sin 37. Am I right or wrong? This is correct. No response.
Yes, sir.
Yes, all of you. Then T1 is equals to T2 into sin 37 value 3 by 5. So can I write as a T1 is equals to 3T2 divided by 5. Let me take this is equation number 1. Anybody having any problem? This 2 is for T. Ellame puriyama. The T is a subscript, not a multiplication. The 2 is a what? Everybody? This is the subscript. Next.
Subscript.
Next, see. T2 sin 37 is equals to what? T2 sin 37 up. Forget about this down, up and down. T2 sin, cos 37. T2 cos 37 is equals to how much? 5z. Am I right or wrong? All of you see that this is x and this is minus x. So x is equals minus x is equals to t sine 37 and plus x is equals how much? T1. Am I right? Please respond.
Yes, sir.
Same way now upward. That is what? T2 cos 37 and down, which is equals to what? Fastly g 5z. Am I right? No response.
Yes, sir.
Okay. So understood, everybody? That's all it is. So means in the sense of what? T2 cos 37, which is equals to 5z. So we all knows that 5 value, g value how much? 10. And cos 37 value how much? 4 by 5 into T2. So T2 is equals to 50 into this 4 by 5 will come this side 5 by 4. Ellame purima? Please respond.
Yes, sir.
Yeah, that is what you have to remember. So now you tell me. So what will happen? I'll make it like a, you can see that what is the answer will come. T2 is equals to 250 by 4. Am I right or wrong? All of you? So which is equals to tension equals to 62. 5, 5,
62.5.
yeah, 62.5 newtons. Ellame purima? Yes, please. Now you tell me T1 value will come less or more? T1 value compared to T2. T1 value will come less or more? At least any guess? Yes or no? So you can see that, experience it. So the position is changes. 9th class you study potential energy. So potential energy, what is that? Suppose a same boy fall from here, suppose a 1 meter, and another the same boy will fall from the
Sir,
10.
next.
Yeah, 10 meters. So where the PD potential energy is greater, everybody, potential energy is higher in where? Higher elevation. Yes or no?
High.
Yes, that is what. So same way here. So who is in higher elevations? T1 or T2? That is should verify. So who is in higher elevations? T1 or T2? T2. So
T2.
T2 always will
T2.
become greater. So I got T2 equals to 62.5 newtons. Then substitute that value in any one equation. That is what T1 you will get it. So we all knows that T1 is equals to how much formula? Fastly. T1 is equals to
3T2 by 5.
yes. So because we all knows that T1 is equals to 3 2 divided by 5. That's all. So 3 into T2 value how much amma? T2 value we all knows that just now we have solved.
62.5.
62.5 Newton.
Divided by. So 3 divided by what will come? Faster. This is 4 or 5 or 3 to 3 3 2 2 by 5 or 4 or 5. Am I correct? Yes.
Yes, sir.
That's all. So divided by 5. So I can write this one as multiply with the 10 in the both numerator and denominator. So it will turns into 3 into 365 divided by 50. I mean, any problem for anybody? So long, Adami. So that is
No,
what.
sir.
If you solve that
Sir.
one, you will get how many newtons? T1 is equals to T1 is
12.5.
equals to 12.5 newtons. So please all of you solve. Okay. So this is how we need to find tension in the strings. So keep in mind one statement you should remember. What is the statement? Same will be the tension, same will be the
Sir.
Yes, Rudresh. Yes, Rudresh.
37.5. No, sir.
37 or what will happen? I don't know exactly. Do correctly. So 3 into
37.5.
yeah, 37 point 37 point.
5, sir.
Okay. I think into it is correct only. So 12.5 into 3. Am I correct?
Yes, sir.
Yeah, because I have solved 625 divided by 50. So if I divide the 50 with the 625, I'll get 12.5 only exactly. So that's fine. I forgot to multiply with the 3. So which is equals to answer how much? Yes, yes.
37.5.
30. Everybody 37.5. That is what T1 newtons. Ellame purima. Understood? All of
Yes,
you?
sir.
Yeah, this is how we need to solve it. Can I give the next question? Yeah, complete this question fastly, everybody. Make it quick, complete it, and we'll continue. Complete, you can tell. Mudinjicha, tell me. Clear, everybody?
Yes, sir.
Yeah. So once it is over, then we'll proceed next one. So let us see. Next question. Find the tension in the both the strings. So I'll make it. Find the tension in the both the strings. The strings are attached to the in such a way that you can see. So this is the actually and mass is attached here. The mass is, let me take root 2 kg. How much kg? Root 2, all of you, root 2 kg. And both the strings are with the surface, both the strings in such a way angle that this angle is 30 degrees and this angle is 60 degrees. That is what you have to remember. Now you tell me, both the strings, actually they are, you can notice it different angles, so that the tension exerted by this one is not same. So this is T1 and the tension, both are different strings. So that this tension will become what? Everybody. The tension exerted by one is T1, another one is what it will become? Fastly.
T2.
All of you? Yes, please respond. T2. So both are inclination. Do you all remember? Nobody will answer. Inclination it is. So every corner it will act two forces. One is X direction, another one is what direction? Fastly. Y direction. So this is another kind of thing. So one force will act X direction, another force will act what direction? Everybody, Y direction. So let me make it here. It makes a theta with a 30 degrees. So that is what it is makes. So with the 30 degrees. So here what will happen? This is T2. So T2 means here what will happen? T2 fastly.
Cos theta.
Cos 30 degrees. And here what will happen? T2 fastly.
Sin 30 degrees.
And opposite here. Here is the 60 degrees. Then here what will happen? T1. It is the T1. So what will happen?
T1 cos 60
Cos
degrees.
60 degrees. And here what will happen? Fastly. T1
T1 sin.
sin 60 degrees. Ellame understood? Fastly, please respond. So for every
Yes, sir.
this I think we are very familiar. We have done so many times. Am I right? That is what. So now imagine a free body diagram. So they are asking, find the tension. Mr. Sai Karthik, can you able to understanding? So find the tension in both the string. That's all. So we have to draw FBD, free body diagram. Am I right? All of you. So if
Yes,
you
sir.
draw FBD, so we all know that consider the entire mass into what? You have to consider entire mass into the point. Am I correct? So one force first. One force which is acting downward direction. We all knows that. That is equals to what? All of you. You should respond it. It is equals to what? Weight. Am I right or wrong? Then we all knows that at the point of intersection. So we all knows one force is acting like this direction with a 30-degree angle. Another force is acting like this direction with how much angle? Everybody? 60 degrees. Clear? And this is actually T1 and this is actually what? Fastly. Yes, T2. Clear? Now, this is only resultant force. Then we have to assume x-axis and as well as what axis? Fastly. X-axis and y-axis. Here what will happen? Theta is here. So that T2 cos 30. And here what will happen? T2 sin 30. Please mark it. Very, very important. Now, I'll change the pens. Now let me comes to this side. So this side also it is having how many? 2. Am I right or wrong? Just I'm showing for your purpose. Both will coincide same line. Am I right or wrong? You should tell me. Yes. So that's all. Then this is the T1. So this is the T1 means here what will happen? T1 cos 60 and again up. What will happen? Here only T2 sin 60.
T1 sin 60, sir.
T1 not T1. Sorry. T1 sin 60. எல்லாமே புரியுமா? Response.
Yes, sir.
That is what you have to remember. That's all. So if you want to find the tensions, then you just equate it. Now from this you observe very carefully. T2 cos 30, which is equals to what? T1 cos எல்லாமே equal, correct guys? That is what? So T1, I will draw only this point. So that point, x-axis and y-axis you check is T1 cos 60 degrees, and this side what is there? Fastly. T2, சொல்லுங்க தம்பி.
Cos 30.
So T1
Cos 30.
cos 60 degrees is equals to T2 sin 30.
T2
Okay. So cos 60 value evala? Fastly. Cos 60 value. Cos 60 value. Make it fast. Cos 60 value how much ra? 1 by 2. That is
1 by 2.
2. Cos
1 by
30
2.
value. Cos 30 value.
Oh,
3 by 2. Clear? Now.
Sir,
Yes.
1 by
Sir, 1 by
1 by
1 by 2.
1
Oh,
by
this is sin 30.
Sin
Sorry, I have
30.
written sin 30. Sin 30 wrong it is. What is that? Cos
cos
60.
30.
Yes,
Cos
yes. Cos 30 and cos 60. So sorry. So cos 60 and here cos 30. So cos 30 value how much ra? Cos 30 value root 3 by 2. Am I right?
Root
2, 3 by 2.
Yeah. Both the
Yes,
sides
sir.
Yes,
root
sir.
2 will get cancelled. So T1 is equals to how much it will come?
root 3
Root
3
3
to
3
2.
T2.
Okay, root 3 T2. So till here you solve. Now today you remember, today I have sent you 2 handbooks of physics. One, both are online. Have you all seen, everyone? Just now one I have sent,
Sir.
evening and morning.
Sir.
Now, everybody try to take the print and as well as maintain the hard copy with you. Both the sides, double sides. Do one thing, don't go for normal printing because space waste and we need lot of money also because further so many things are there. 2 pages you can print in 1 page like this. Okay, if you are comfortable, okay. If not, 1 page, after 1 page you can fill it. Normally you can print it, but if you want side by side also you can, but it's very very small, difficult to read. So better if possible go with a double side, but you all must have that both hand like printouts, and as well as before one physics handbook I have given. Do you all remember that?
Yes, sir. Yes.
That handbook also you should maintain the hard copies. Once you maintain, someday definitely I'll say you what you have to do with that. Okay, but you must have, everyone keep it in mind that. Okay, so now T1 equals to root 3 T2. This is what you have done. Next, anybody tell me next to see that next point, upward and downward. Tell me downward acting something. What is that? Root 2 into G. Upward
Root
rendu
3.
force irukka. Upward rendu force irukka. What is that? T2 sin 30.
2 root 3.
And next one is what? T1 cos.
Sin 60.
Okay, that's all. So both are same direction. Addition or subtraction? Addition. Okay, so T2 sin 30 plus T1 sin 60
Sin
is
60.
equals to root 2 into 10. G value is 10. Am I right or wrong? Fastly.
Yes,
That is. So you can proceed with that. So T2 into sin 30 value 1 by 2.
1 by 2.
1 by
T1 value, sorry, sin 60 value root 3 by
Root
2
3 by 2.
equals to root 2 into 10. What will come? 10 root 2. Am I right?
10 root 2.
10 root 2. That's all. Next you see that. So again, let me take now. We have so if you take, let
Sir,
me
we
take 2 is the
can
LCM. Yeah, 2 is the LCM here. Already
T1.
what will come? T2 plus root 3 into T1. Am I right? Root 3 into T1
Yes,
is
sir.
equal to this one? No. Correct? Am I correct? Please respond.
Yes, sir.
Yes, sir.
Yeah, both LCM is same, which is equals to 10 root 2. Now 2 is in division. Will come this side. What will become? Everybody?
Multiplication.
Multiplication. So root 2, and you can see T1 value. Tell me. 3 into T1 value. How much we got?
T1 value we can substitute.
That is only I'm going to do now, Rudresh.
Root 3
Root
T2.
3 T2.
Root 3 T2, which is equals to 10 root 2 into 2. Am I right or wrong? Because it will come like
Yes, sir.
Yes, sir.
root 3 into root 3, how much? 3. Correct? 3 to 2. because root 3 into root 3 whole square, square and root will get cancelled. Any problem for anybody?
No, sir.
So T2 plus 3 to 2, how much it is? 4 T2 is equals to
4 T2, 22.
T2 is equals to
5 root 2.
4.
5 root 2.
So 4 ones are 5, 4 5s are. So how much is the answer?
5 root 2.
5 root
5
5 root 2 newtons. That is what the T1. Any problem? For now, we went, sorry, T2. So T1 we can find it easily because we all knows that T1 is equals to what? T1 is equals to
root
what?
3 into
3 root 2.
Yes.
Root
Root
3
into T2. Okay.
T2.
So root 3 into T1 value how much? 5 root 2. So which is equals
5 root 2.
I will write it as a 5 root 6. Any problem?
Root 6.
2 into 6.
Okay.
That is what it is, T1. Okay. So this is how we have to find the tensions in a given string. Any problem for anybody, you can ask. Clear? Yes?
Yes, sir.
Now. So as I told you, normal reaction force. Do you remember normal reaction force, everyone? Yes? Yes, please. All of you respond. That is what. So normal inclined force. So we'll use this question. So what is that value in inclined surfaces? All of you observe very carefully. I'll draw the inclined surface now. You must understand this. This we all people knows that. So in inclined surface, suppose this is the mass of the object M. We all knows that G is acting down. Sorry, W is acting downward direction. That is what, which is equals to what? Fastly. S mg. So we all knows that like this coming, it is actually not perpendicular, it is inclined surface. So that x-axis something is acting. Can you tell me? Of course, it is making a theta angle here. Then we all knows that it weight is acting downwards. Normal will act always perpendicular to that. That is what N. Am I right, everybody? All of you? Yes. And it is not released. It is attached
Yes, sir.
to some rigid body. Attached with some rigid body. Then always tension which is going away from it. Tension going away from it. We'll consider as a what? Fastly, you should say. It is equal so much. Everybody? It is equal so much, guys. It is equals to T.
T.
Okay. That is what you have to remember. Now, this is what my body. We are all very familiar. So as it is, mg is the resultant force. Then x-axis, what will happen? We all people know last, before class also we studied so many times. This is mg is like a resultant force. Then x-axis and as well as y-axis. So here is the theta. So here what will happen? Actually, mg is the resultant force. So here what will happen? Mg cos theta.
Cos.
And here what will happen? Mg sin theta.
Sin.
Am I right? So we all knows that in x directions, who will act? Mg cos theta sin theta. Sorry, not mg cos theta. This is what, everybody? Mg what? Mg sin theta and perpendicularly to that. That is what? What is the angle between them? 90 degrees. Perpendicular to that. That is what it will act. What it will act? Mg cos theta. Remember, everybody? And you see that when it is inclined surface, always this vertical is neglected because the force is exerting in two different directions. One is towards the x-axis, another one perpendicularly to that. So that is what is that? Y-axis. That is what? So mg cos theta, and here how much it will come? Fastly. mg sin theta. Okay. So let me
Sin
consider.
theta.
M is a object. Then the tension is acting T. That is what first, because it is an inclined surface attached to that in the figure. So tension is T, and one force is acting almost obliquely. That you can see that because it is not a plane surface. So if it is not a plane surface means we all knows that. So this is the actually the force which is acting, normal force which is acting. So then this both, what is the angle? Anybody can tell me? Normal and the tension. Yes, please. What is the angle between them? You should tell me.
90
90.
degree. 90 degree.
Then one force is acting downward direction. That is what we used to call as weight. Weight equals what?
mg.
Weight equals what? mg. Okay, wa? All of you understood, ma? So it is like an inclined surface.
Yes, sir.
Imagine like, just imagine that this is the inclined surface of x, and this side who will come? Minus x. Okay, wa? Now, this side it is a y, and this side down it what will come? Fastly.
Minus 1.
Okay. Now it is making a triangle. You all can see this is the triangle. So inclined surface. So it is making a triangle like this. This is the triangle which you are all can able to see that. Let me just imagine. So if you imagine like this, then all of you observe here. Here is the what is the angle? We all knows that. Here what is the angle?
Theta.
Fastly. Then here what will become? 90 degrees. Can you able to see the picture? Perpendicular. Am I right or wrong? How much it is?
Yes, sir.
Here
Yes,
is the
sir.
90 degrees. 90 degrees. Then here how much it will come angle? Anybody can tell? Here what is the remaining angle? This is theta. This is 90. So then what is that angle? Anybody can tell? Sure. This is already 90. Triangle means how much, Ra? Triangle means what?
Sir,
180.
90 minus theta.
Yes, very good. 90 minus theta.
90 minus.
Okay,
Yes,
that
sir.
is what it is. Any problem for anybody? You can ask. Okay, guys. So here it is the
Sure.
theta, and here is the 90 means 90 degrees means here how much is the angle? Fastly, everybody. The angle will
90
be how
minus
much?
theta.
90 minus
90 minus theta. I will write it here. 90 minus theta. That is the reason. Always you have to remember something. If you are studying, you do not have any kind of deviations and all. Perfectly you focus. That's all. So if you imagine here, so we are having for totally 4 things now. So theta, what total angle is equals to 180 degrees. So if I imagine x-axis and y-axis, so we all people knows that. So in this action, x-axis tension is acting. So that is what T. Okay, finished it. Now normal is acting what direction? Normal is acting upward direction. That is what normal reaction force. Then the angle between them is how much? Tension on this one. How much we got it? 90 degrees. Then the resultant force acting downward direction, which is equals to how much? The force, that is what weight. So weight is equals to mg. Then if it is mg means here observe very carefully. This is what will happen. Theta will come here. Here is the theta. So this is the theta means then here how much it will come? Fastly. Theta means here what will come? All of
90
you,
minus theta.
90 minus
2
theta.
minus theta.
Because all of you observe very carefully. This fully 180 and this fully 180. Is it right or wrong? You should tell me. I should not. Okay,
Sir.
wow,
Yes,
everybody
sir.
clear? So that is what. So if here is the theta, then here what will happen? Mg cos theta.
Cos.
Mg cos theta. Then this side what will happen? Mg
Sin theta.
mg.
Side theta.
Okay, so that is what you have to remember. So we should not use, all of you should remember, we are not supposed